Hello learners, welcome to your favorite e-learning platform Pathshala. I'm Savita Chauhan, your mathematics mentor. Let's just start a new chapter today. So in our day-to-day life, we have come across with certain kind of statements. Like suppose I'm saying that it probably will rain today, or if I'm saying there are 50-50 chances that India will win the match today, or if I'm saying that I doubt that he will pass the test today or not. So all these statements do involve some special kind of the words like probably, 50-50 chances, or I doubt, and all these words are actually do involve an element of uncertainty. What does it mean? It means if I'm saying that it probably rain today, it means that it may or may not rain today. And for example, if I'm saying this, it means that I have a past experience related to it, that when it rained actually under that similar condition. So it means that we can predict, or we are predicting certain kind of situations using the words probably and 50-50 chances, or if I'm saying I doubt. So all these are nothing but the predictions which are actually based on our past experiences, definitely. And thus these uncertainty of the words probably, 50-50 chances, or other such words can be measured using a very special mean of something which is nothing but called as probability. And this is nothing but our chapter today, fortunately. And definitely we do know that probability actually starts with gambling, and after that it has an extensive use in not only the biological sciences but also in the medical sciences as well. And after that it do have a use in weather forecasting a lot. So this is all about a new chapter which is nothing but called as the probability, but probability with an experimental approach. So let us suppose if I'm talking about an experimental approach, what does it mean? Let us suppose if I'm tossing a coin. If I'll toss a coin, then we do know that this is nothing but all about an experiment. This is all about an experiment, that I'm tossing a coin. If I'm saying that I'm throwing a die, what does it mean? It means I'm doing an experiment, that I am throwing a die. So what is probability as an experimental approach? It means we are actually doing an experiment, and on the basis of that experiment we are gathering the data, and then we will talk about the outcomes of it. So this is all about an experimental approach. Based on the experiments we are deducting the results. Now let us suppose if I'm saying that I am tossing a coin. If I'll toss a coin 10 times, let us suppose if I'm saying that I'm tossing a coin 10 times, and if I'm tossing a coin 10 times, let us suppose if I have tossed a coin 10 times, then on the basis of this particular data, I am saying that the number of heads, so it is an actual experiment that I am doing. So let us suppose if I have tossed a coin 10 times, then I'm counting the number of heads and the number of tails. I'm counting the number of heads and the number of tails that would come up when I am tossing a coin 10 times. So let us suppose if my outcomes are just like the number of heads are nothing but 4 and the number of tails are nothing but 6. So when I have tossed the coin 10 times, and the number of heads that showed up is nothing but 4, and the number of tails were like 6. And let us suppose if I am tossing a coin 20 times, let us suppose, or 40 times, let's say if I'm tossing a coin 40 times, and then the number of heads that comes up or shows up is nothing but 24, let us suppose 24, and the number of the tails that comes up is nothing but definitely 16. Let us suppose if I'm saying it is 16, 2, 3 and 4, it is 16. So let's just find out their probability. So we know that how we can find the probability of getting a number of head when a coin tossed 10 times. So that would be nothing but, let us suppose if I'm talking about this one. So when we were talking about the 10 times, when a coin is tossed 10 times and I'm talking about the probability of getting a head. So this would be nothing but definitely 4 by 10. We know that how to find it. The number of the heads are nothing but 4 and the total number of the times we have tossed a coin is nothing but 10. So this is nothing but 4 by 10 number of heads divided by the total times it is tossed. So this would be nothing but 0.4. As you can see, this is nothing but 0.4. And similarly, if I'm talking about a probability of getting a tail, so probability of getting a tail is actually nothing but 6 by 10. It is actually 6 by 10, which is nothing but 0.6. And let if I'm tossing a coin 40 times, let if we are talking about the tossing a coin 40 times and getting the probability of head would be nothing but 24. As you can see, the number of head is nothing but 24 out of how many times? 40 times. Not now we are not talking about the 10 times, we are talking about the 40 times. So now the total number of the times a coin is tossed is nothing but 40. So as you can see, this is nothing but 24 by 40, and if I'll sort it out, this would be nothing but 2 and 1, and this is nothing but 2 into 2 is 4, and this would be nothing but 2 into 2 is 4 and 0, and further this is nothing but 2 into 6 is 12, and then we have 2 into 3, this would be 2, 1 and 0. So this would be nothing but 6 by 10, which is nothing but point of 6. And further, if I'm talking about probability of getting a tail, this would be nothing but 16. The number of the tails is nothing but 16, and it is out of nothing but 40. So let us suppose if I'll sort it out, so this would be nothing but 1, 0, 4, 4, and this would be nothing but 0.4. Let us suppose if I'm increasing the number of times a coin is tossed to approximately 100 times. Let us suppose if I'm tossing a coin 100 times and the number of head that showed up actually is nothing but let us suppose this is nothing but 49. This would be nothing but 49, and the number of tails that showed up is nothing but 51. So if I'm talking about the 100 times when a coin is tossed, when a coin is tossed, then the probability of getting a head at that time is nothing but 49 by 100, and as you can see, this would be nothing but 0.49. and further, if I'm talking about getting the probability of tail, this would be nothing but 51 divided by 100. So what is the probability that we are getting? We are getting 0.51. So after this particular experiment, when we have tossed a coin 10 times, 40 times and 100 times, there is a pattern that is coming out of it. And what is that? That whenever we are tossing a coin more and more times, or increasing the number of the times a coin is tossed, the probabilities of getting a head and getting a tail is approximately getting equal to be 0.5, As you can see over here, when we have tossed a coin 10 times and the probability of getting a head is 0.4, when we have tossed it 40 times, this is 0.6, 100 times 0.49. In the similar way, if I'm talking about the probability of getting a tail, 0.6, 0.4, 0.51. So approximately the probabilities of getting a head and getting a tail is approximately tending to 0.5. So this is nothing but an experimental approach of our probability, that always the probability of getting a head or getting a tail is nothing but a 0.5, that is nothing but half. So the probability of getting a head or the probability of getting a tail is nothing but always half and half. We all definitely know about this fact, but it is all that this result we are getting through this kind of an experiment. So I have just taken only three experiments, that when I toss the coin 10 times, 40 times, 100 times. You can take more than this. You can take either 1000 times or 1500 or so goes on. But you will always get the same result, that always the number of the times that you are increasing the tossing of a coin, the probability of getting a head or the probability of getting a tail is always approaching toward 0.5. And in the similar way, if I'm talking about throwing a die, then if I'll increase the number of times of throwing a die, then their probabilities of getting a number 1, 2, 3, 4, 5, 6 would definitely tends towards 1 by 6. It would definitely tends toward 1 by 6, and that's why the probability of getting a number 1 on a die is nothing but 1 by 6. Getting a probability, or the probability of getting a number 2 on the die is 1 by 6, and so goes on. So this is all about an experimental approach in which we are actually performing an experiment. We are actually performing on an experiment, and on the basis of the actual data that we have gathered from this experiment, we are concluding a statement that the probability of getting a head or tail is nothing but this. So always remember, whenever we are increasing the number of times of tossing a coin, then the number or the probability of getting a head or the probability of getting a tail will always approach towards a number that is nothing but 0.5.